Today, we're going to pull back the curtain on this incredible, invisible network of systems that's all around us, designed to keep us safe in the buildings we walk into every single day.
You know that sound, right? That piercing alarm? It's an experience we've all had. But it's not just noise. It's actually the opening note. Behind that alarm is an entire orchestra of engineering, a symphony of safety, all working together. So let's dive in and see how this amazing performance actually comes together. So, where do you even start with something this complex? Well, it turns out that all modern fire safety, whether it's for a small shop or a massive skyscraper, is really built on three core ideas.
Think of it like this. Pillar number 1, life safety. That's just about getting everybody out safe and sound. Pillar 2, fire protection. This is about actively fighting the fire, trying to put it out. And Pillar 3, structural safety. This is absolutely crucial, making sure the building itself doesn't collapse while the first two things are happening. These three pillars, they're the foundation for literally everything else we're going to talk about.
Okay, so let's get into our first layer of defense. This is the stuff that you probably walk past every day and don't even notice. These are the silent, always-on features that are built right into the building's DNA.
And right here, it's super important to get this distinction. You have passive protection, which is like the building skeleton. It's just there, always working, creating barriers. Then you have active protection, which is more like the building's reflexes. It only kicks into gear when it senses danger.
So the main job for these passive systems is just to buy us time. They do that by basically putting the fire in a box. You've got firewalls that chop the building up into smaller compartments. You've got fire stops that plug all the little holes where pipes and wires go through. And then you have what's officially called the means of egress, which, is really just a fancy term for a clear, protected path to get outside.
So what's with this number? 2 to 4 hours. Well, that's the fire resistance rating you'd find on a typical firewall. It means that wall is guaranteed to hold back a fire for 2, maybe even 4 hours, stopping it from spreading. That's not just time, that's literally a lifeline.
Okay, so how far should you ever have to run to get to an exit? The building codes are incredibly specific about this. In a residential building, say an apartment block, it's 30 meters. And to give you a feel for that, just picture a basketball court. You should never be further from an exit than the length of that court. And of course, in more hazardous buildings, that distance gets even shorter.
Here's another one of those magic numbers for you. 24 meters. As soon as a building gets taller than this, the rules change. Suddenly, just having staircases isn't enough. It's now legally required to have a refuge area, which is basically a protected balcony where people can wait safely for firefighters to come and get them.
All right, so the passive systems are doing their job. They're holding the line. But what happens if the fire keeps going? Well, this is the moment the building itself wakes up. This is the active response, the alarms, the detectors, the systems that are designed to actually fight back.
Now, before you can fight a fire, you gotta know what kind of fire it is. I mean, you wouldn't throw water on an electrical fire, right? That would be a disaster. This whole classification system is key because it tells you exactly what tool you need for the job, from the fire extinguisher on the wall to the huge systems in the ceiling.
We've all seen sprinklers, right? But do you know how they actually work? It's not the smoke that sets them off. Nope. It all comes down to a really clever and beautifully simple piece of physics that's hidden inside one tiny color-coded glass bulb.
And here it is. This is the trigger point, 68 degrees Celsius. That's about 155 Fahrenheit. When the air right around that sprinkler head hits that exact temperature, well, that's when the show starts. So that little red bulb is filled with a glycerin-based liquid. And as it heats up to precisely 68 degrees, that liquid expands and pop! It shatters the glass casing. That action releases a plug, and water just unleashes itself directly onto the fire below. It's just a brilliant piece of design. So simple, so reliable, and it doesn't need any complex electronics to save lives.
So, everything we've talked about, it just gets way more complicated the higher up you go. In a skyscraper, you can't just stroll out the front door from the 50th floor. The problem becomes vertical, and that means the solutions have to be vertical too.
In a lot of places like Delhi, for example, high-rises have this whole other set of really demanding rules. They need a special fire lift, one that's built to keep running even in a fire so firefighters can get up there fast. They also need their own massive, dedicated water tanks, so they're not relying on the city's water pressure. And they have a fire command center, which is basically mission control, on the ground floor where every single system can be tracked and controlled.
Okay, that was a lot of information, I know. So let's do a quick pop quiz. Let's see what you'll be on the lookout for the next time you're walking around a big building.
First question. We talked about how far you should ever have to travel to get to an exit in, say, your apartment building. Do you remember what that magic number was?
The answer is 30 meters. And remember, this isn't just some random number. It's carefully calculated based on things like average walking speed and how long it takes people to react, all to make sure you can get to safety fast. That basketball court analogy, it's a great way to actually picture it.
Okay, question number 2. Let's think about that tiny glass bulb in a sprinkler. If that bulb is red, what's the temperature it's designed to activate at? And the answer is 68 degrees Celsius. Yep. And while you can get other colors for different environments, like a really hot boiler room might need a higher temperature bulb, that red one is the standard. It's the one you'll see almost everywhere.
All right, last question for you. At what point does a building get so tall that it needs one of those special safe balconies for people to wait for a rescue?
The answer is 24 meters. As soon as a building crosses that line, the whole game changes. The escape strategy is different, and that safe refuge area becomes a totally non-negotiable part of the building's design.
So, you see, a building isn't just concrete and steel. It's a guardian. It's this active system that's constantly working to protect you. The next time you walk through a door or look up at a ceiling or glance down a long hallway, what are you going to see differently now? What will you notice first?